Hello and welcome back to Compiler Programming. Today I thought I would start working on making more high-level abstractions for our values so that we don't operate the things that are that just defined for our CPU and the instructions, but something more high level. And in particular, I think we will need to have a way to represent functions and maybe later arrays pretty soon. So let's start with like the simple things, which are integers and, as I mentioned, functions, because we will need them. I have no idea how this is supposed to look or work, so we'll just kind of start slowly chipping away at that. We will need to have some kind of struct, obviously, that will hold our stuff. Let's call it value. Same as with the operand, we will also need some way to say what is the type of that struct. So what's the type of that value? So value type. What could be the value type? It can be integer or it can be a function for now. And I have no idea yet what would be the best way to represent an integer. Signed and unsigned ones. Like, should I create separate types, or should I just have like a flag that tells me if this is a, for example, unsigned integer? I don't know. So for now, we will just treat all integers as signed ones. And this might cause problems in a couple of places, but overall, I think we can live with just having signed integers for a while. So let's just say value type integer and then value type function. As far as integer size, this is also another choice that I will need to make, because we already have byte size in the operand, but it might be worth it to have separate size here. And the reason is, for operands, byte size is more or less fixed, in the sense that it is either like 1 byte, 2 bytes, 4 bytes, 6 bytes, 8 bytes, and potentially, I think, 16 bytes for AVX registers. And it can't be anything else, right? But for values, technically there is no limitation what is the size. So I'm not sure how to best deal with this. So let's do something simple first. So we say value type, and then we obviously need to represent a union. So union, and here let's say, so what will the integer hold? I guess, I don't know. Right now, let's say it doesn't hold anything and see if we need it. And then we will have function, which should have a function descriptor or just function. I think we should change up slightly how we currently do functions to, like, what we currently call function should be called something else. It should be something like function builder, I guess. And then when we are ready to when we have finished building it, we will receive a function object back to us. So let's do that change. Let's call it function builder. Actually, we did figure out arguments. I think we can also remove this comment for now. And let's start fixing function builder, function builder, function builder. There's okay. Looks like I got everything. Okay, so this is a function builder. And now we can take up function as a value type. And let's go back here and say type def struct. Although maybe it is worth to call it like a full thing. So value function. Yeah. For consistency, and you'll have value integer, and so on. So what should value function have? I think until we start generating actual executables, which I honestly don't even know when it's gonna be, or if it's gonna be in this code, or it will be later in the language itself. Until then, we don't need to manipulate offsets, but we rather always have to do with memory. So functions, in that sense, always need to have an address. And it's always going to be even consistent. It doesn't matter if we ourselves created that function or this is an external function that we are importing from a DLL, or just like straight up putting from our main program, which right now is in C. So, okay, we have address, but C has undefined behavior for function pointers. So I guess we'll need to have something like, I don't know, function type. I guess void to void will be our base type of the function. I don't know, like, but yeah, I guess, but void to void will be also a bit of a misdirection about what that actually is. Basically, we want like a opaque function type, same as void star for data. We want like void star for functions. So let's then type def function type void to void as function type opaque. And this is what we will store. Address. Okay, so we don't know what the type is, but we need to store it. This is a situation where it would be nice to have a more complicated type system that we could express some stuff like this. So, but obviously C is very, very basic. So we have to deal with what we have. Okay, as an address, it needs to specify a return type, and I guess return type will also be like, we can't make it a value because so value actually should consist of two parts. It should have a type, and it should have storage. So maybe this is actually wrong how I modeled it right now. What we want is so this is not really value. Let's call it descriptor. Descriptor type. Okay. Let's call that descriptor type. And then we have descriptor function. And then we also will have type struct descriptor. And we should move this actually after here, because the second part of this definition, descriptor type, descriptor, actually not descriptor, like this. Yeah. Something like this. Type, then we have a union for type function, descriptor function, and then yeah, so maybe something like this. Value is just a combination of descriptor and like where it is stored. Maybe later on I will rename this from operand to storage, and then descriptor just tells us kind of all the information about this type. And for, as I mentioned, for function, the address is should not really be part of the descriptor. It is the part of the operand where we just where we just say what is address. And if we know the address ahead of time, like if this is something that we pass in from C to our code, then this would be just immediate operand. So this should not actually go here. This doesn't exist. And we just will be interpreting the operand differently depending on the descriptor. Instead, what function should have is descriptor for for its return value. Or let's call it returns. And then it also should have a bunch of descriptors for arguments. And then obviously, because it's C, we also need to do something like S64 argument count. Okay. So our function will have a bunch of descriptors for its arguments and has a descriptor for its return value. Seems reasonable. Maybe though we should have the return value and arguments as values. Because what I'm thinking about is who will hold the knowledge about how to map different storages for arguments to where they are. So like right now we only support integer arguments and they are stored in registers. But if the argument is larger than 16 bytes, then it will be passed on stack. And also more than that, technically you have different calling conventions. Even within the same system, you sometimes can have multiple calling conventions. So in the end, maybe it is nice if the descriptor actually contains all of that information, that it tells us kind of where the arguments would be for the function body. Or not even the function body, also for the caller, right? So the caller knows where to put different values. Okay, let's think how this would play out. Obviously now we need to do some forward declaration of struct value. And it also means we can't really include this as a value because we don't know the size of this struct here. So I guess it's also gonna be value star. So we're gonna start now leaking memory like crazy, but I don't care at the moment about memory, so we'll just ignore this problem. Okay, struct value has a bunch of arguments, has a return value, great, and then we have our descriptor, and yeah, that sounds about right. We still can build, but obviously the fact that we created this structure doesn't mean anything. So let's figure out how we can use something like this. And again, probably want another editor just so that I can reference this stuff in the code below. Okay, so let's just look at what we have here. So we have declare variable. Right now, this returns to us an operand, but probably we want it to return a value instead. So let's see. Or maybe let's start with the function. So function begin, what does it do? This is fine, this does not really change, but here is where the changes actually start. So when we say we want an argument, we need to start working on that. So maybe our builder actually needs to also contain a descriptor for the function. So say descriptor function descriptor, and when we create an argument, actually when we do function begin, we need to allocate some space for our arguments. So let's do that. Function dot descriptor dot arguments is malloc size of value times whatever. Right now we can even do 4, and then here we will assert that, yeah, I mean, we already asserted that we don't support more than 4 arguments, but we can even add this, again, this linkage, so we can later find out places where we need to change this to here. Okay. So we reserved some stuff. We need to say something like this. Let's check if this still builds. Can it convert from const descriptor? Yes, because this is actually descriptor function. Good. We have this descriptor, and now whenever we add an argument, we want to make, like, kind of add this argument to the list of things in the descriptor. Since we have this nice next argument index, everything is great. So instead of just saying return RCX, like ideally we should not pass byte size into here. What we should pass instead is a descriptor. For our stuff, right? Because, and then here, so when we say I want this function to have this argument, for example, I want this function to have S64 as the first argument. So I not only should say what is the size of that, but I also should say what is the like where it would be stored here, and then together they make up the value, which we'll put in side arguments. Sorry, a bit babbly today, but it's fine. Let's move on. Function. Now we can't. Actually, we can. So we say function descriptor. Actually, it's gonna be like this: descriptor dot like arguments. Actually, like this: descriptor arguments 0 is what? That's a value. That value contains descriptor, and that value contains operand. And operand, we already know it is, like right now we are more or less hard coding it to be RCX. It doesn't really matter if we are passing an integer or a function, because both of those fit into a register. So for now, this is fine. And we'll need to later deal with sizes of argument, but for now, this is not what we're working on. And descriptor is just descriptor. As easy as that. And now we can return this value. Good. We can do the same thing. So let's change the return type of the function, and then we can do the same thing here. Const value arc. Yeah. Now we no longer have byte size. That is very true. So here's one, and this is RDX. This is R8, and this is R9. Here we return 3, 2. Can't convert from value to operand. Did I make arguments operands by accident? No, it is a value. So cannot convert from value to value. What? That does not seem to be a... Cannot convert size T to descriptor. I don't understand this error message. Ah, okay. Yeah, this is an error on my part in forward declaration. It should be like this. Yeah. And here is fine. So since now this doesn't return an operand, this breaks obviously, but I think we should first fix up other functions before we move on to this one. So function return. This is where I'm not sure if we need to really change anything. I guess maybe it should accept a value instead of an operand. And then it will just like kind of take out operand from the value. But honestly, we can also do it on outside for now, so it's fine. So let's fix that. Operand arg0. Now we want to probably will need to create these descriptors for integers. And question is, do we want to have a size in the descriptor? Let me think about that. Okay, let's do the simplest thing. Let's just inline the definition for now and then figure out how we're gonna improve it later. So if we say type is descriptor type integer. Okay, that's fine. No, it's not. Value arg0 and arg0 0 operand. Yes, this is better. Okay. We have, obviously we'll need to change all the plus functions and whatever else we have to our new value stuff, but let's go step by step and get to compiling program as fast as we can, and then do the next step and then the next step. Okay. 2 should be like this. Here we take this stuff. This is value. This is value. Okay, making some progress. Slowly but surely. Okay. 1, 2, 3. And then arg2 operand. Great. Let's check out how horribly we broke stuff. And we actually did break our increment. Okay. Let's check this out. Yeah, we don't actually need this here. Yep. Great. So we are making slow but steady progress. Now since we have arguments, we can also have the return type of the function. So we will need to change up how this function return actually works. And if we actually say that value, like we change operand to value, then suddenly everything is exactly how we want it to. So first here, let me allocate some memory for our return. And then in return, we want to actually use that memory. So let's just say function descriptor returns, or to that memory, we copy what was passed to us. And if you think about it, this actually probably will be quite neat. So in a sense, we have sort of type inference for the return value, because we just say, okay, I want to return this value, and the resulting function object right away knows what will be the return type. Right now, obviously, that is always the same thing, but it's still kind of neat. If it works out later on, that is. So here, it should be to return operand. Yep. Oops. Wrong button. This should be arrow. Okay. That's fine. Now, now we need to wrap these immediates into a value. Well, that's fine. We can do that. Again, for now, I will just do it by hand, and then we will see what's the right way to do it long term. So descriptor is const descriptor type like this, and then brand. Might make sense to separate this in several lines so it's not so unreadable. Right. Oops. Bit lost. Okay. Operand equals. What don't you like in this stuff? Maybe I don't need to do this. You still don't like this. Okay, now it's better. And since we changed to return to accept a value, we no longer need to do this. We don't need to do this. Okay. Here we need to wrap our stuff in a value, same as we did here. Because we are just proxying stuff. That means that we do need to create an anonymous value that is kind of only exists for this stuff. Operand is arrayx. I said arrayx. But like in reality here, what should happen is we will get in like we should get a descriptor of that function, and then we should use that descriptor for determining what to return here. But we don't yet have the descriptors for external functions, so this may be something we will need to do later. Okay. And the same thing, I guess, here. Yeah. Function return. Unfortunately, it's the same here and the same here. And here we can actually simplify. Good. Let's check again our tests. Our tests do pass. Okay. What is next? I guess would be neat if we can use this for the calls, right? So that we, instead of just passing a raw pointer, as I mentioned, we pass in a function descriptor. What would that look like? we have two functions that call stuff to play with, and we need to figure out which one is the one that we are gonna tackle. And I will not touch this one because in a sense right now it's more generic than what we would like, but this one seems like a good idea. So instead of it accepting like this raw address of the C function pointer, we would make it accept a function descriptor. Okay, it accepts a descriptor. And then what should it accept as argument? As argument, it should accept now a value, right? Yes. I don't know. Partial argument 0. Okay. So how does this change? Arg0. Let me think for a moment. So we get the descriptor of the function. We are saying that we will return to you a new descriptor of the function. So it should return me this. And this new descriptor, actually, it should return me a value. Oops. And that new value will, in the same way, contain address of that function that we created, but it also should tell me all the encoding stuff. So we create this new function. We actually, when we do function begin, what we should be doing also is to create an immediate value in the operand. Let me think about this. Maybe we say something like function value function end. It accepts function builder. And what we'll do is it will return a value where descriptor is function descriptor, and then as an operand we will get immediate 64 that contains the address of the buffer, right? Because this is in the end what we are calling. So we can do this stuff, right? It should be like this. And long term, it will be inconvenient if we always use immediate 64 because of the way the calling works. But for now, this actually should be quite nice. So we have function end. Here we do function end of function. Okay, that's good. Now we just need to figure out what the hell needs to happen here. And this is a very good question about should I actually keep this as a value, or should I make it into an actual known thing? Well, let's keep it actually as like this just for now, and see later what we want to do with it. So the reason I'm not sure about this is it's a bit tricky to keep in your head what is kind of should be runtime, what should be, so which part of the code should return to the JIT code, which part of the code just refers to kind of our C runtime, and which part is even hard coded. So like those three needs to be very carefully separated, and right now they are a bit mixed up in my head, so I will just keep it as is and instead focus on the calling part. So do we have like a call helper? We do not yet. So let's create one. What the call helper would look like? Yeah, actually, original function should not be a descriptor function, it should be a value. And we say value call value function. And then we also need to pass arguments to it. So this is where it's might be a bit awkward in C to deal with that. I guess we can use something like this. So like variadic function for this call, and then rely that this specifies correct number of arguments, but this is a bit yuck. I'm not sure I'm super in love with this idea. So for now, I guess we will do it like this. Call 1. Value arg 0. Not very nice, but it works. Okay. The first thing that we need to do is we need to assert that function descriptor type is actually, here we can pass by pointer, I guess. Function descriptor type is descriptor type function, right? If not, then we can't call it anyway. So this is the very beginnings of our type checking. Not very fancy, but it will have to do for now. Function, function. So this is how we will call the stuff. So we will always shove it into arrayx, and we will need to think like, I think we should always consider arrayx completely volatile. So we will never ever try to retain a value there, and like consider that the next instruction will always override arrayx. So if we do anything with arrax, we immediately need to save it somewhere else, either into different register or into stack memory. This is probably the only way to keep us sane. Okay. Now we have argument 0, and here instead of immediate we say argument 0 operand, and here we need to say to do type check arguments, but this is definitely for later, or maybe even fix me. Okay, so we move first operand to array x, and then we call array x. Actually, no, we shouldn't move first operand. We should move function operand to array x and then call. But we also do need to deal with argument, and here we should, like, this will actually fail in certain cases for stack probably, like, but for now it will probably succeed. And move, and then here function arguments 0 operand. This is a pointer, so we need an arrow. And then here is argument 0 dot operand. Something like this. We can do another assertion here actually. We can say that function descriptor, well, first let's check that it actually has valid memory, and then also we can say that argument count is 1. So we are not yet type checking the arguments themselves, but at least we are starting to add a bit of scaffolding to catch errors as we kind of execute this. Okay, this seems reasonable. So we are storing the argument where it needs to go. We are moving our function to array x. So even it doesn't matter if it's immediate, it's stack, or it is anything else. This will always work. This will not always work. Like if both of those things, for example, are on a stack, we actually need to do some conversions, but for now, this is fine. And then we call array x. And then for the return value, it's also pretty straightforward. We return function returns, right? And this way we are hopefully removing a bunch of hard-coded stuff here. So all of these, let me for now comment out, because we might need this stuff later on. But right now, we can just say call one of original function. Actually, here we can also do like this, and we call it with arg0. This is starting to look more and more like a nice DSL. So or domain specific language. Let's see if it also works nicely. Okay, that does not seem to be working. So here we need to return actually a copy of the function returns. It should be function descriptor returns. Still no dice. function descriptor function arguments. Okay. Yeah, it should be like this. Maybe it is worth to extract this descriptor function. Descriptor is this. Yeah. Yeah, this should be a bit nicer to deal with than what we had previously. This is fine. Function operand is actually like this, yes. And then here we do descriptor returns. Okay. You're still not happy with this stuff. Okay. Yeah, it needs to have a builder. Let's call it toCall. And then we say function builder star. Let's rename it to builder. Still not ace. Guess it should be like this. Okay, getting closer. It's no longer called function, it's called toCall. Okay. And the last one, I guess, is this. Okay, great. Let's rename it to builder as well. Here. Okay, great. And great. Function end is incorrect. Builder. So it should be builder descriptor. Oh, that should be fine. Not sure what is wrong with this. Builder cannot convert from what? Descriptor function to descriptor type. Yeah. So this should be like this. Descriptor type function. And then function is this. Okay. Better. Builder buffer memory. Yeah, I guess we need to convert this from a pointer to just a value. Great. This is fine. And now we just need to fix up our calling side of this. So what will the calling side look like? I guess we will need to have a value ID is 64 value. And here we'll need to describe what it is, right? So descriptor again is okay, descriptor type function, and then the actual function we also need to do stuff. Okay, so we need another value that is going to be describing our argument 0. This one is going to be, we can copy paste it from somewhere here. Yeah, this is basically this stuff, right? This is a descriptor is this, and then we don't really need right now, we need operand. And what is our operand? Wait. Okay, operand is REX, or sorry, RCX. So if when we change make identity to be the same thing, we actually will not need this stuff here. But for now, I have to write it myself. Okay. Say arguments is arg0. Like obviously it's also not safe to just keep it on the stack, but for the test it's fine. And we say argument count is 1, and then we say returns is, so also again need to have this like this, returns integer in RAX. So returns is returns. Okay. So this is a descriptor for our identity function. And now we are missing just the operand, and the operand will be immediate 64 casts to S64 of ID S64. Okay. This returns to us, so let me get this type and then say value shell function value. The answer is, so we need to, like, we get back a value and then we need to turn it back into something that C can understand. So we'll need to cast this back to the right thing. Function value operand this. I believe it is like that. And here we pass in our ID S64 value. Okay, bunch of errors. Let's try to understand what they are. These ones are pretty simple. Forget semicolon, forget colon here. Make partial application. It expects a pointer. And this does build. I have no idea if I messed something up. Apparently I did. So it's debugging time. Close this thing. and open up Visual Studio for debugging. Let's go to our new function. Let's just, visually recheck everything. So argument 0 is in RCX, that's correct. It returns to us in RAX, that also seems correct. And the actual operand, all of this seems fine, so probably the error is in here. Let's check. And then we go inside of this function and start. So let's check first what is our arc0. Descriptor is integer. That's correct. And operand is a register. It's register index 1, which is RCX. So that seems correct. Let's get into the call. So assertions obviously pass, otherwise we would not be able to even get to the correct side of the test. Okay, we have descriptor. Argument count is 1. Argument is integer. It is in a RCX register. So this is what we want to call. So we are moving from our descriptor arguments. So from our argument, we into descriptor arguments. That seems fine. And then we move the address to call into RAX. Then we call RAX and we return whatever the descriptor said would be returns, which is register 0. So all of that seems like fine to me. Let me check what is this value. That also probably seems like a valid function. We can actually compare it with ID S64. And it is different. So this is slightly weird. Why is this different? Oh, this is different because I'm actually not returning the right thing. I'm supposed to return or am I? Let me think about this. No, this is the right thing. So it's the result. Actually, we need to do this. Maybe this is why it crashes. Function return. Function return. Yeah, because I forgot to do this. And it still needs to return stuff. We are calling, but we are not returning this. Okay, let's check again. Okay, now it does not crash, but it doesn't work either. So what is going on? Well, let's see what was the generated assembly that we are trying to call. Where is that call again? Ah, it's here. Great. So stub RSP 8. Move RCX. That's fine. So what is inside of RCX? It is 0. That's kind of strange. Why is RCX 0? Oh. Yeah, that's not correct. So our arg0 operand is actually the wrong thing, because this partially applied function doesn't actually have an argument. The only thing it has, like, we need to create that value ourselves. Value well, we can still call it arg0 or applied arg0 is this, right? It's a descriptor and then immediate or operand is immediate 64 of S60 of arg. So this is what should happen, not what I was doing before. And it works. Good, so we can clean up all of that. I think this video has run long enough. I know it was a bit lengthy and not very eventful, but I think we are slowly but steadily making good progress. In particular, I think that this setup with ability to actually call stuff is very important for us to start doing more real programs in this setup. I think in between videos I might do a bit of cleanup and convert, for example, these functions to work the same way as make partial application, and it also will allow me to clean up the test here. But I don't want to make you sit through that, so for now, that's it. Thank you for watching if you survived till now, and see you next time.